Hello guys, welcome back to my channel Data Science with Gagan. So today in my video I'm going to share one more computer vision project. So as in my last video we saw how to do object detection using YOLO v10 model and how to train it on our custom data set. But this time in my video, in this video I'll show how to do object tracking on top of the object detections that we will get from the YOLO v10 model. And yeah, as similar to previous videos, first we will go through some concepts and then later on we will look into the coding part where we will do some inferencing part and we'll create a small application, right? So you can see in the screen, this is going to be our content for this video. First we will go through DeepSORT, what is DeepSORT and how it works, and then we'll go through its inferencing part, and then in the end we will create a small application where we can put a video and the system will track will do a tracking on it and return the tracked video. Okay, so let's start with DeepSORT. So what is DeepSORT? So basically it is a computer vision tracking algorithm which is used to track the objects while assigning each of the tracked object a unique ID, and it is an extension of the SORT algorithm, or you can say it is a type of SORT algorithm where DeepSORT introduces deep learning SORT algorithm by adding appearance descriptor to reduce the identity switches and hence making the tracking more efficient, or you can say it is defined as a tracking algorithm which tracks object not only based on the velocity and motion of the object but also based on the appearance of the object. So this is how DeepSORT works. So now we will look into its working, how basically DeepSORT algorithm works. But before getting into its working, first we will go through basic SORT algorithm, how basic SORT algorithm works. So here in the screen you can see it is an approach to object tracking where Kalman filters and Hungarian algorithms are used to track the objects. And basically it is consisting of four major components, which are detection, estimation, data association, creation and deletion of the tracked IDs. Now what are these components? So first component is which is detection. So as first step, objects needs to be detected using any object detection model so it can be tracked further. Then these detections are passed to the next step. Now second component we have, which is estimation component. Here in this step we used to pass all the detections from the current frame to the next frame to estimate the position of the target in the next frame using Gaussian distribution and constant velocity model. The estimation is done using the Kalman filter. Now the third component we have, that is data association. We now have all the target bounding box and the detected bounding box. So a cost matrix is computed as the intersection over union distance between each detection and all the predicted bounding boxes from the existing targets. Now the last and fourth component is creation and deletion of tracked IDs. Okay. Now here when any object is about to enter or exit the frame, then unique object IDs are created or destroyed accordingly. So this is all about the working of basic SORT algorithms, but there are some problems, or you can say there are some limitations of using SORT algorithms that we can use that we can solve using DeepSORT algorithms. But first we will go through like what are what are those problems. So here you can see there are two major problems with SORT algorithms, and these are deficiency in tracking to occlusion, fails in case of occlusion and different viewpoints. Second problem that we have is despite the effectiveness of Kalman filter, it returns a relatively higher number of ID switches. So these are two major problems that we faced while using SORT algorithms that we can solve using DeepSORT algorithm. Now we will see how our DeepSORT algorithm solves this problem. So here you can see these issues are because of the association metric used. So in DeepSORT we use another distance matrix which is based on the appearance of the object, the appearance feature vector, which is deep appearance descriptor. This DeepSORT uses a better association metric which combines both motion and appearance descriptors. So using these metrics, DeepSORT algorithm overcomes the limitation of basic SORT algorithms, right? So till now we saw how what is DeepSORT algorithms and how it works and how it overcomes the problem of basic SORT algorithms. Now we will look into the inferencing part, where we will implement DeepSORT using YOLO v10. Okay. So now let's start with the inferencing part. So here we will see how can we do a inferencing on the video using this DeepSORT algorithm. So we can track the object in the video. So any kind of object you can track. Suppose so for this video we are going to use pre-trained YOLO v10 pre-trained model. So what we will do we can select any common objects like birds and cars that we want to track. So if you are using this algorithm for any specific person, specific task, right? So what you can do, you can train your model on your custom data set, and then you can track that object but accordingly. So for this then it's all about what kind of objects you are going to track. So if you want to track multiple objects at the same time, or if you want or you want to track only one object at a time, right? So we can do both things. So here we will see we will see how to track one object at a time. So here you can see first I'm here in this line, right? I'm downloading the weights YOLO v10 model, which is the extra large weight, and then here you can see I'm loading those weight using this YOLO v10 class. So we can have a model here, and then here we are giving this path, so we can use this weight for feature extraction purpose. So as I told, right, we for in DeepSORT, right, we use a feature map, right, which is another matrix along with the IOU, right, that we use to calculate. So we can easily estimate the target in the next frame. And then here you can see I have written some basic functions which are the drawing utils. So we can have attractive bounding box in the frame, right? So and then here you can see this is a function which will return what classes are there for that particular class boxes that we have in the frame, and what are their bounding box coordinates, and what are at what confidence level they are getting predicted. Okay, and then here this is the main part, you can see, right? So here we are reading this file, right? Basically this is a video file. So we are going to read this file, and and we are going to track each frame, right? And we are going to read each frame and track. We are going to track the objects in each frame. So here you can see first we are reading, and this is from the it depends on the source, right? If you want to read a file, then you can mention the path to that particular file, and if you want to take a feed from the live camera, then you can give it a 0 or 1 or a code to a particular device. Okay. So here you can see once we will read the file from the source, then here we are getting the frame weight, frame height, and at what fps it is reading the file. And then here we are creating the object tracker using the DeepSORT. So here we are passing this DeepSORT weight, and then max age and innate max IO distance. If the distance is above, then is greater than or equals to this distance distance, then only we are going to track that object. Then we are initiating some lists and some variables here, and then here we are giving while true. We will keep reading this video until we reach the break condition. Okay. So here you can see, right, it return if it is returning something, then only we will process with the video. So if it is returning, then we are going down, right? Then first what we are doing, we are converting VGR to RGB, and then what we are doing, then we are giving that frame to the model, and then model is returning returning some results. So we are having this function. When we will pass this function, so here you can see, right? So then what we are doing, here we are getting all the class names from the models, and then what you can see, right, we are giving this results dot boxes to this function, and then we are getting all the things as I told above, right? And then what we are doing, then we have put it a condition, as I told, we are going to track up one object at a time, right? So suppose for this case, I'm going to track this car, right? I'm going to track a car in this video. So what it will do, and and it should be and the confidence value should be more than 0.4. This condition I have put it here. Then if it matches, if the result or the input matches this result, then only we will consider those things, right? And then then if it matches, then we are going inside this condition, and we are taking those bounding boxes and those particular confidence values, And then here you can see I'm converting those boxes list to the array. And then here you can see, like, using the bounding box that we get from the first frame. On the basis of those, we are updating the tracker. And then once we will update this tracker, and then what we are doing here, you can see, right? We are assigning, we are creating the bounding box from the updated tracker, and then we are assigning the IDs to that particular bounding box, right? So here you can see, from the tracker we are getting those bounding box. And then here I've given some colors, like, if the ID can say, right, if I then we have three colors, right? Then we, like, if ID is 1, if ID is if ID but divided by 3, and we are getting remainder 0. Like, if remainder is 0, then we are assigning color red. If it is 1, then we are assigning color blue. And if it is 3, then if it then 2, right, then we are assigning color green. And then here we are calling this util function to draw the rectangle. And then we have a draw label, like, so we can give so we can write a text over the bounding box using this function. And then here, we are also, and also one more thing that we are doing here, like, we are creating a list. So we are creating CSV file, right, for all. So we can store all the information related to every object that occurs in the that occurred in the frame, right? So here, using this, like, if, so here one more thing, let me tell you, like, yeah. So here what we are doing, like, we have created one empty dictionary here, previous details. So, like, it will contain all the details related to the previous frames. And then we are storing everything here. And then you can see here, right? And then here, once, suppose if there is any object which has exited the frame, then what we are doing, we are storing its information into a CSV file, and then we are deleting that particular object from the previous details information. Okay. And then here you can see, like, I have written the logic for that purpose. And then here you can see, like, we are doing other things, right? Like, what is the frame number, and what is, like, at what FPS we are processing the video, right? So we are doing everything here. Now let's see, like, what it returns. Okay, I guess we haven't. Let it run. Let's. Yeah, so yeah, first time it will take time, but when I'll run it continuously, then it won't take much time. Let's wait. It's run. Yeah. So here you can see, like, this is the video, and and the system has started tracking this car. Like, you can see, like, how many frames are there, and what is the time, and how many counts are there for that. The object that you have selected. Like, if it's a person, then it will track the person in the video. And if it is any object, the object that we have specified, then it will detect the specified object. So in such a way, you can see, right, like, it has, like, if any other car will be there, then it will be car 2. So in such a way it works. You can see, like, so hope you got this, right? So now what we will do, like, we saw, right, like, how can we track the object in a particular video, right, or in the live video. So now what we will do, like, we will create an app where we will put our video, right? Like, if even we can put some recorded videos, or if we want to take video or live feed from the camera, then we can do that also. So we'll see how. So here we will see how can we create an app using Streamlit. So we can track the videos. Either it could be the recorded video, or either it could be the live video. from the camera. So here we will see how. So basically we are going to do same things as we did in the upper part, like where we were reading the stored video, and then we were tracking the object, or we were tracking the car in that video. So we are going to do the same things here. You can see, like, in the similar way I have loaded the path, I have loaded the models, and then here you can see, like, it's in the similar way I have initialized all the list, dictionary, and some variables. And then, like, and you can see, like, I have created one function here, which is that function which is that we will use to track the objects in the frame or in the video. Because now I have created this function because, like, in the application, we are giving two options to the user, whether he can select, basically there will be two options. If he will select the live feed, then the system will take the input from the live feed, and if he will select the camera, right, if he will select the recorded video, then the system will proceed with the recorded video. So, right, like, instead of writing this logic again and again, it's better to write it once and let's call it again and again. Okay, so here you can see, let's see, like, how this app will look like in the browser. So let's do it. So let's tracking. Yep. So we are streaming streamlit run app.py. Let's see. It's running. You can see here. Let's wait. Okay. So here you can see, right, as I told, like, there will be two options, like, whether you want to run it on local video or whether you want to run on live feed. So here you will get two options, and accordingly, if you, like, here you will get the list of all the objects, right, which object you want to track. So here you can suppose I'm going to track the person in the video, in the local video, and here are some configurations, right, like at what detection threshold, right, this is the, you can say, confidence value, right, then what max IOU distance should be there, and what should be the mean confidence there, and, like, at what, like, distance should be there, right, max distance should be there, like, and there I have given one more option, like, if you want, like, we are tracking this video here, right, if you want to record that video, then you can click on this option. So what will happen, you can see here, it's recording, like, then what you will have to do, you can select any video here. Suppose I'm going to track this video. So here you can see, like, it will start tracking this video here. It's in running state. Here you can see, right, person 1%, when you can see the count is 2. Like, if there will be 3% and more than 2%, then it will reflect the count accordingly. Here you can see, like, at what frame rate we are processing this video and how many counts are there, and what is the frame width. Once it will done, what you will see the output video here, and that information related to objects below that video. So let it complete first, and then we'll see, like, what will be the output. And it's up to you, like, what kind of information you want to show on the screen. You can select as per yourself. like it's according to me, like what information I can show. And one more thing, like it's not mandatory, like like you can only reflect these information from the videos. It's up to you, like what kind of information you want to track from the video, like from how, for how much long time, like the user was like the object was there in the frame, right? And what is its color, everything you can you can track. So you can see like the video process, right? So like it's processing. Once it will process it, it will come here. So let it complete first. And one more thing, right? Like if you will manipulate these values, right? So it can impact the how it can impact the performance, of the model, and you might see the difference in the results. And also like what you can do kind of cache things, right? Like suppose if a user is giving this video again and again, so right, so you don't need to process it again and again, right? So what you can do, like if you find like this is a similar video which has been which has been processed in the past, so what you can do in that case, you can return the same output video for that particular input video, okay, and the same CSV file. Let's see like what is happening in the backend. You can here you can see like it has been processed. Yeah, you see here you can see it's quite slow. So here you can see like this is the output video, you can see, right? And like it has been detected to object ID 1, like now, and here you can see like what is the bounding box color for each person, and you can see blue, and person 2 is green, and like at what frame number they had exited. So here you can see like this video has stopped there at this frame number, right? So it's there, and for how much milliseconds they were there. And also right here I know I've given this link, so you can download this data. So if you will click on this link, so you can see like this file has been downloaded in your local system, and then you can go through this CSV file for the further details. So this is how this application works. Hope you got like how to create an application, and you can add multiple things to it. Let's see, like if you if I want to run it on live feed, so let's see the live feed. So here it will ask you like which device you want to select, whether like if you are having multiple webcams, right? So accordingly you can select 0, 1, 2. So suppose like this is the first camera, right? Like which I have selected here. So here you can see like it is processing me a person one, right? Like if there will be another person, right, besides me, then it will take that person also, and it will give that it will assign the ID to that person accordingly. So let's stop this camera and then see like what it returns. So now I have stopped this camera. So here you can select its processing, and then you will see the similar kind of output here for this video. So here you can see like once I have been there, like here you can see, right, and how many times for how much duration I was there, and at what frame number I exited. And similarly you can download the details from here, right? So in this way this application works. Hope you like it. Yep. So I guess I think you will like this video. And so yeah, this is all for this video. We'll see you in the next video, and we'll come up with different ideas. And let's meet in the next video. Bye, see you.
To keep me motivated for more videos on data science projects, please do like and subscribe. And please do not forget to press bell icon for notification of new projects videos.